Behind the eyes of this long extinct human is a mind capable of great technological potential. While the species to which it belongs will cease to exist, future generations of its evolutionary kin will live on, largely due to the innovations it brought into being. At first glance, a chipped rock may not seem like much, but to the hands that shaped it, it was a tool, a key to survival, an extension of thought, a symbol of ingenuity. Long before the written word, before metallurgy, and before large civilizations, our ancestors were engineers of stone. With each precise strike, they weren't just breaking rock, they were unlocking a world of possibilities. Stone tools are often dismissed as primitive, yet they represent some of the most profound breakthroughs in human history. They required planning, skill, and an understanding of the natural world. The people who crafted them were not mindless brutes. They were problem solvers, innovators, and experts in material science, long before the concept even existed. There is a hidden complexity to the Stone Age, and to understand these tools is to understand the very roots of human intelligence, culture, and success. So how did our ancestors select the perfect stones? How were these tools crafted, and what does their evolution reveal about the way we think? These are questions we'll be answering in this video. And as you'll see, stone tools have shaped us just as much as we've shaped them. Evolution isn't just a biological process. It can be applied to technology as well. Just as natural selection shapes organisms over generations, artificial selection, driven by human need, shapes the tools we create. The earliest stone tools were crude, often just simple flakes or cobbles with sharp edges. But over thousands of years, these tools became more refined, more efficient, and more specialized, mirroring the selective pressures that drive biological evolution. The process works similarly. In nature, traits that increase survival and reproduction become more common in a population. In technology, designs that prove useful are more likely to be passed down, while inefficient or outdated tools are abandoned. Just as organisms develop adaptations to changing environments, stone tools evolve to meet the shifting needs of their users, whether for cutting, scraping, hunting, or even symbolic purposes. This technological evolution is not random, it's guided by human hands and minds. Early hominins may have started with basic rock smashing, but over time they learned which stones fractured best, which shapes were most efficient, and which techniques produced the sharpest edges. Those lessons were transmitted across generations, leading to an ever-growing arsenal of tools that shaped our human history. But how many generations back does this go? It's not unreasonable to suggest that our last common ancestor with chimps around 7 million years ago may have used stone tools. Primatologists have observed it in modern monkeys and apes. Macaques will use two rocks, one as an anvil and one as a hammer, to crack open nuts. One fascinating study published in 2023 looked at the assemblage of stone flakes that are produced from these behaviors. They note how the assemblage is landscape-wide, almost indistinguishable from early hominin flakes, and that the assemblage produced by monkeys would likely be identified as anthropogenic in origin and interpreted as evidence of intentional tool production. Chimpanzees have been observed performing similar nut-cracking tasks. A 1997 study reported 692 episodes of chimp infants as young as 3.5 years old using stones to crack oil palm nuts. Interestingly, archaeologists excavating a site in Ivory Coast, Africa, suspect they have discovered 4,300-year-old stone artifacts produced by chimps. Starch residue analysis suggests that they were used for nut cracking. The stone material used and the density of that material matches what modern chimps have produced at other sites. The researchers conclude by saying, the geological, morphological, technological, metric, and mass parameters for the nut-cracking stone assemblage reported in this study rule out human or natural agency. The nut species cracked all belong to a set of taxa known to be exploited by modern chimps, and part of the starch assemblage may belong to species exclusively consumed by chimpanzees. They go on to say, the systematic archaeological study of prehistoric chimpanzee cultures suggests that the quote-unquote chimpanzee Stone Age started at least 4,300 years ago, that nut-cracking behavior in the Thai forest has been transmitted over the course of 200 generations, and that chimpanzee material culture has a long prehistory whose deep roots are only beginning to be uncovered. These primatological discoveries are truly awe-inspiring, and I can't help but wonder how advanced their technologies would become if left to evolve on their own accord. That said, in the hominin or human lineage, it's not just the use of stones, but our intentional and advanced manipulation of the stone to improve its efficiency that separates us from these other primates. The Paleolithic or Old Stone Age marks the initiation and evolution of our stone technology. Most of our evolution was spent in this period. It's traditionally divided into three broad periods: lower, middle, and upper, each marked by advancements in tool construction and shifts in human behavior. These periods reflect not only the physical evolution of our ancestors, but also the growing complexity of their cognitive skills, social structures, and survival strategies. The lower Paleolithic is where the story of human technology truly begins. The earliest known tools, discovered at Lomekwi, Kenya, and dating to 3.3 million years ago, predate even the genus Homo, to which we belong. The artifacts here are hardly recognizable as such, especially to the untrained eye. They are crude stone cores and flakes made mostly from basalt and phonolites. It's believed that these ancient hominins were using techniques similar to the aforementioned primates. Instead of holding the targeted core in a free hand, it is placed on a surface, like an anvil, and then struck with another rock. The Lomekwi knappers were predominantly using both the passive hammer technique, in which the core is held in both hands and struck downwards onto an anvil, and the bipolar technique, in which one hand stabilizes the core on the anvil and the other strikes the hammer down vertically onto the core. It's hypothesized that an ancient hominin known as Kenyanthropus platyops created these tools, being that this was the only species existing around the area that long ago. Oldowan tools were similar to Lomekwi choppers, appearing with the emergence of Homo habilis around 2.5 million years ago. This was the first widespread stone industry. These tools have been found across East Africa and consist of larger cobbles and flakes. They may have served various functions, but the flakes were likely used for defleshing meat, while the cobble choppers were used to crack bone and extract marrow. A significant leap was made after Homo erectus came on the scene about 2 million years ago. They are credited with developing the Acheulean industry. The most notable stone tools associated with this industry are the Acheulean hand axes. What separated these from previous technologies was their symmetry. Rather than one irregular edge, Homo erectus created hand axes through bifacial flaking, meaning both sides of the stone were carefully worked to create two sharp edges. This technology would be the first to make its way out of Africa, following the migrations of Homo erectus and continuing through the later species like Homo heidelbergensis. This is a great example of the coevolution between humans and our tools. The more refined and effective Acheulean industry aided the success of early hominins, allowing them to leave the confines of Africa. This effectiveness likewise led to the replication and propagation of the tool style. The Lomekwi, Oldowan, and Acheulean industries were what defined the lower Paleolithic. The transition to the middle Paleolithic occurred around 300,000 years ago, and lasted until about 50,000 years ago. By this time, human populations had begun developing more regionally specialized tools with different shaping techniques. It's a period closely associated with Neanderthals in Europe and Asia and early Homo sapiens in Africa. These Middle Paleolithic people devised and implemented the Lavawa technique. This technique was more advanced than earlier ways of making stone tools. It involved carefully shaping a stone core before striking off flakes. First, one end of the core was prepared as a striking platform. Then its edges were trimmed by removing small flakes around the outline of the intended tool. This process gave the core a rounded dome shape, similar to a tortoise shell, hence the name tortoise core. When the final strike was made, a flake broke off with a sharp, curved profile, already shaped and ready for use. Contrary to the opinions of early anthropologists, this Neanderthal technology was complex and required considerable hand-eye coordination, says anthropologist Clark Larson. In northern Africa, Assyrian tools made by early Homo sapiens defined the period between 145 and 29,000 years ago. Spanning from Morocco to Sudan and adapting to shifting dry and humid climates, Assyrian tool kits included stone and bone tools, featuring advanced implements like bifacial foliates, blades, perforators, burins, and tanged points. These tanged points refer to stone tools with a distinctive tang or stem at the base, which would have allowed them to be hafted onto handles or shafts, making them more versatile as spear points or knives. Hafting stone tools to wood and creating these more composite-like tools is an emergent feature of the Middle Paleolithic. It suggests a significant advancement in tool technology as it allowed for better grip, reusability, and potential repair. The Upper Paleolithic, starting approximately 50,000 years ago, marks a true explosion in human culture, and stone technology was no exception. It was a golden age of innovation, driven by the emergence of fully modern Homo sapiens. Toolmaking became an art, with finely crafted blades, bone tools, and even sewing needles appearing alongside stunning cave art and personal ornaments. The period also saw further regional diversification, as groups in different parts of the world developed distinctive tool traditions. The Aurignacian, Gravettian, Solutrean, and Magdalenian cultures left slender blades, microliths, and laurel leaf points across Europe. People who settled in Japan toward the very end of the Upper Paleolithic, around 16,000 years ago, had their own stemmed points and microblades, with obsidian being their material of choice. The Americas, having been discovered sometime before 16 to 20,000 years ago, is home to some of the finest stone tools in all of archaeology. It's arguably the pinnacle of the Paleolithic. This is partly because farming and sedentary society did not become widespread, at least in North America, until much later than other parts of the world. And contact with westernized societies didn't happen until the 15th century. The prolonged dependence on stone resulted in a plethora of cultures that truly refined their tool-making abilities, the most notable being the Clovis point. Clovis points are attributed to some of the earliest nomads to inhabit the North American continent. Earlier traditions, like the Western stemmed tradition, have been discovered, but what made Clovis people so special was their innovation of the fluted point. They crafted bifacial projectile points, with the addition of a concave channel that runs upward from the base called the flute. For a deep dive into these points specifically, I'll leave a link to my Clovis video in the description. But to put it briefly, fluted technology likely facilitated hafting points to spear shafts. This made weapons more durable and effective for hunting large game. The technique later influenced other cultures, such as the Folsom and Dalton traditions, which extended fluting further up to the distal or tip of the point. The skill and precision required to craft fluted points highlight the advanced craftsmanship and adaptive ingenuity of early hunter-gatherers in the Americas. And so that was a broad overview of the evolutionary path that stone technology took, but we still have so much to explore in this video. Where did these prehistoric people find the right stone material? How did they make their tools, and what did they use them for? So now let's dive into the life cycle of a Stone Age tool. In archaeology, we call this the study of lithics. The first task necessary for creating any stone tool is to find and acquire the right stone or lithic material. Not any old rock will work. Some rocks are more suitable for a given function. Finding the right one can be tricky because you need something hard enough to hold an edge but not so brittle that it shatters easily. While ancient humans might not have articulated it the way we do today, they learned to identify stones with key characteristics, making them suitable tool materials. Studies have shown that Paleolithic people became more selective in the types of stone they used over time. For example, some of the highest quality stones these people foraged for are referred to as cryptocrystalline. This means that their crystal structure, or what we perceive as texture, is too fine-grained to see with the naked eye. It can even be difficult to distinguish the grains when looking at a thin section through a microscope. Some of the most common cryptocrystalline stones we see in the archaeological record are chert and its offshoots like flint and jasper. These sedimentary rocks are formed over millions of years in marine environments as nodules or bedded layers within limestone. They have conchoidal fracturing properties, which simply means that the way they break when struck creates smooth, curved surfaces resembling the inside of a seashell. They break in a predictable, controlled way that can produce a sharp edge. Other non-cryptocrystalline rocks share some of these fracturing properties too and were widely used in prehistoric times. These include things like obsidian, which is a volcanic glass formed when lava cools rapidly, making it an extrusive, igneous rock. Quartzite, which forms when sandstone is subjected to heat and pressure, causing the quartz grains to fuse together into a hard, dense rock. And argillite, which is also formed under immense heat and pressure, but is rich in clay. Its fracturing properties are slightly less predictable than the others. The hunter-gatherers of the Stone Age would have been highly efficient at navigating their environment. They would have noted important locations of vital resources, created mental maps of their whereabouts, communicated them with each other, and developed migration routes around them. The search for quality toolstone led early humans to geological outcrops, riverbeds, and eroded hillsides. Natural bedrock formations where high quality stone was exposed are considered primary sources, whereas riverbeds and glacial deposits where water and ice transported tool grade stone are considered secondary sources. People would have relied on both. Prehistoric quarries show evidence of recurring usage over hundreds or thousands of years. The mid-Atlantic and northeastern United States, where I work as an archaeologist, are home to many of these quarries. Extensive chert and argillite-bearing formations run through Pennsylvania, New Jersey, and New York, where Native Americans acquired much of their material. Since at least the 1890s, researchers have known about the ancient Jasper mines of Pennsylvania. Archaeological excavations near Glen Falls, New York, uncovered prehistoric mining activity, including chert quarry debris, deep mine pits, and extensively damaged bedrock surfaces. The researchers of this quarry developed a model to explain the progression of quarrying activities at Glen Falls specifically, and might be able to be generalized elsewhere. They say chert extraction began at a surface quarry, with the reduction of chert boulders that were naturally exposed along an outcrop of moderately dipping beds of late Cambrian age Whitehall Formation dolestone. The surface quarry was probably short-lived as exploitation of the resource intensified and progressed into a ledge quarry. Large volumes of angular chert debris were generated as blocks of chert were pried and hammered loose from the ledge and reduced to quarry blanks. The ledge quarry progressed into a pit quarry as the extraction zone was advanced deeper into the hillside. The deepest depression within the shallow quarry pits represented the last active extraction zones when the pits were abandoned. After the lithic material was acquired, they often traveled long distances with their nomadic owners. For example, the Clovis-aged Plenge site in New Jersey contains stone tools made from Munsungun Lake chert, extracted in Maine about 800 kilometers to the north. Studies of Shirataki obsidian exploitation and circulation in prehistoric northern Japan show that the geographic distribution of this material expanded throughout the Upper Paleolithic. However, it was complex, with periods of expansion and reduction, analogous to something like glacial and interglacial periods. By the way, I explore some more of my local archaeology in my free newsletter, which you can find a link to in the description. I'll also leave a link to my ebook down there too. Sometimes locations of stone resources incentivized prehistoric people to develop base camps around them, similar to their affinity to waterways. Archaeologists studying the Welling site in Ohio, which consists of a chert outcrop, argue that it represents a base camp or hub where Clovis hunter-gatherers would have gathered for more than just material extraction. Various tools have been discovered at the site, and use-wear analyses suggest that hide scraping, meat butchering, bone and antler sawing, and plant scraping all took place here. So after identifying and gathering the proper stone materials, prehistoric people then modified them to fit their needs. Flint knapping is a term we use to describe this behavior. A skilled flint knapper has great control over the stone, using its fracture properties to their advantage. Starting with a large core stone, the knapper will likely begin by gradually striking it with another rock to flake off large chunks and remove the cortex, or outer surface, of the rock. This is called percussion flaking. After the core is prepped, Pressure flaking is often performed with an antler to further refine the tool's edge and improve durability. If necessary, the tool may be heat treated to make the stone easier to work with. This process has become extremely refined, exemplified by exceptionally precise and detailed stone tools. From our Oldowan days to the days of Clovis, people acquired physical, cognitive, and social traits needed to flint knap with such skill. Physically, the hominin lineage evolved certain characteristics that are needed to make this Stone Age progression. The first was walking on 2 feet many years ago, which freed our hands. Walking on all fours or using our hands to navigate the trees would have preoccupied us, keeping us from spending time creating tools. Second, we have dexterous hands and opposable thumbs, which are critical for the fine motor skills of toolmaking. Anthropologists often use terms like power and precision grip to describe the ways apes and humans can use our hands. For power grip, picture holding a hammer. For precision grip, picture holding something like a pencil. Both are essential for flint knapping, the former being used for percussion flaking and the latter for pressure flaking. Toolmaking also depends on higher level cognition. Our brains are certainly to our advantage here. Studies suggest that even the most ancient toolmakers had an understanding of fracture mechanics, a degree of control over percussive gestures, and a visuo-spatial understanding of the locations and angles to strike a rock. Experiments show that compared to Oldowan tools, Acheulean tool manufacture, in addition, requires the integration of higher-order motor planning, working memory, and auditory feedback mechanisms to attend to information from multiple modalities, as the toolmaker coordinates the different goals required by this more complex task. We can infer that as time progressed through the Middle and Upper Paleolithic, so too did these cognitive traits. Our sociality was also adaptive for tool making. Without culture, humans are helpless. We are group dependent and tool dependent, especially when young and compared to other animals. Our group species nature allowed us to transmit knowledge to one another, including how to create stone tools. The degree to which tool making directly caused any of these adaptations is unclear. That said, it's reasonable to suggest that these physical, cognitive, and social adaptations were reinforced by the demands to create stone tools because they were so adaptive. Just as we selected for optimal stone materials, the tools selected certain traits of ours. Like I said in the intro, stone tools may have shaped us just as much as we have shaped them. They conferred countless adaptive benefits to ancient humans. The practical applications of stone tools were essential for survival, enabling people to hunt and process food more efficiently. When attached to a wooden shaft, stone points gave humans the ability to kill at a distance. Broad spears, atlatls, and arrows for bows put humans at the top of the food chain. Once caught, the game would be easily butchered. Many points would double as knives for separating meat from bone. Lomekwi, Oldowan, and Acheulean tools, and generally larger hammerstones, allowed prehistoric people to break bones and access the marrow. This would typically be a niche for hyenas or other scavengers, but now the upright apes could capitalize on the scraps too. Scrapers were designed specifically to help remove flesh and fat from hides, preparing them for tanning. Aside from meat, plant processing also became more efficient. Sharp flakes were used to cut fruits and tubers into smaller portions for easier consumption or cooking. Grinding stones, or querns, were used to process seeds and grains into flour. Some Upper Paleolithic cultures began developing mortars and pestles, also for grinding seeds, nuts, and plant material. All of this would have increased the amount of calories people had access to and reduced the amount of energy needed to acquire them. Maintenance was also required. Over time, tools dulled from repeated use. Knappers would resharpen edges through retouching, flaking off small pieces to restore sharpness. If it became too small or damaged, it could be reshaped into a different tool. A broken spear point might be modified into a scraper or drill, for example. This practice was particularly common in areas with limited access to high-quality stone. When you're a hunter-gatherer, recycling is necessary, inevitable, and almost comes naturally. The end of a stone tool's life cycle is what we archaeologists hunt for, since we can't see these tools in action. They played a vital role in daily survival, but their eventual discard provides valuable insights into the behaviors and cultural practices of early humans, too. Some tools were simply abandoned after they became too dull or dysfunctional, while others took on symbolic significance, being intentionally cached or placed in burials. The way people treated their tools at the end of their use life tells us not only about practical decision making, but also about the deeper cultural and symbolic meanings attached to these objects. When a tool reached the point where it could no longer be resharpened or repurposed, it was often discarded at the site where it had been used. Flakes produced during knapping were often left behind at workshop sites, forming dense scatters of lithic debris. We find these at archaeological sites all the time. Large quarry sites, such as those found in North America and Europe, contain layers of chipped stone where toolmakers worked extensively. Some flakes, though originally considered waste, were later collected and used as expedient cutting tools. Projectile points that were damaged beyond repair were often discarded in hunting camps, kill sites, or while migrating. These discarded points provide archaeologists with clues about hunting strategies, prey species, and tool production techniques. In some cases, broken points may indicate failed hunts, showing where a projectile struck but did not kill the animal. In some cases, stone tools were not merely discarded as waste, but were instead intentionally placed in specific locations for ritual or symbolic purposes. Large deposits of unused or finely crafted tools, known as caches, have been found in various archaeological contexts. Some caches may represent emergency supplies left behind for future use, while others appear to have been placed as ritual offerings. Caches of finely crafted Clovis points have been found with red ochre. These include the Fen cache near the border of Utah and Idaho, the East Wenatchee cache in Washington, and the Simon cache in Idaho. These people saw their points as more than just tools. By painting them with red ochre, they were evidently imbuing them with symbolic meaning, despite our current inability to decipher that meaning. The Sloan site in Arkansas has produced a large assemblage of Dalton tools, which were essentially a later offshoot of Clovis points that sometimes retained fluted technology. Archaeologists also discovered what they believed to be a Dalton-era cemetery here. Accordingly, researchers had this to say about the Sloan burials. Based on comparisons to the point assemblage from other campsites, we conclude that individuals were buried with their personal active toolkits that still carried utility. Many people were also buried with large, high-utility points. Whether these points were made specifically for burial or were objects taken out of their systemic context and freshly resharpened, the large points buried at Sloan represent a symbolic investment of great wealth, and in this ritual context, were ceremoniously placed with the dead for use in the afterlife. The one and only Clovis burial we have evidence of, the Anzac site, also included a large assemblage of over 100 points and other stone tools. Gravettian burials are some of the richest in Upper Paleolithic Eurasia, often containing elaborate grave goods, including finely crafted stone tools. One Gravettian burial of two young boys in Russia dating to around 30,000 years ago included a variety of stone tools. Double-edged javelins, spears, and daggers with beveled proximal ends and awl-shaped distal ends were all found in association with these boys. Clearly, they held a deeper meaning than their simple functions for food acquisition or self-defense. Other Gravettian burials, like that of the prince found in Italy, included more obvious forms of symbolic material culture, like a head cap made of perforated shells, pendants of mammoth ivory, and a flint blade that was placed in the prince's right hand. By the way, we don't know that they were an actual prince. Archaeologists have also discovered that this symbolic affinity towards stone tools probably wasn't restricted to Homo sapiens. Shanidar Cave in Iraq is the site of one of the most famous Neanderthal burials. Here, excavations have revealed the remains of 7 adults and 2 infant Neanderthals dating to between 65,000 and 35,000 years ago. One of the remains, Shanidar 4, was found with clusters of pollen from wildflowers, suggesting the body may have been deliberately covered with or surrounded by flowers in some sort of funerary practice. However, this claim is still debated. Evidence suggests that Shanidar II received a ritual send-off, as a small stack of stones and several church stone points were placed over his grave. Additionally, a large fire had been burned nearby. Could these small stone relics represent the earliest tombstone? It's an interesting thought, and one that inspires us to understand our ancient relationship with the natural and supernatural worlds. For millions of years, stone tools were more than just objects. They were extensions of human thought, ingenuity, and survival. As we shaped them, they shaped us in return, refining our hands, sharpening our minds, and strengthening our social bonds. Their life cycle, from raw stone to precision instrument, mirrors our own evolution, both from nature, adapted to purpose, and ultimately left behind as artifacts of our existence. Even as we've moved on to more modern technologies, the imprint of stone tools remains in the way we problem solve, create, and innovate. They were humanity's first great invention, and their legacy still lingers in every tool we craft today. The story of stone tools is, in many ways, the story of us. For more on life in the Stone Age, check out the video on the screen. Make sure you like and subscribe to support the channel, and go subscribe to my free newsletter for additional Evolve.2 content. I'll see you in the next video. Stay curious.